Radio waves are part of the electromagnetic spectrum, which also includes X-rays and visible light. Generation of radio waves uses the relationship between electricity and magnetism. If an electric battery and a magnetic compass are joined in a circuit, whenever you complete the circuit, the compass needle moves. The magnetic field that has been created can also be detected in another circuit placed near to the first. This is how radio waves travel across space. With powerful transmitters, they are sent very long distances and picked up by an aerial on the receiver. To send complex signals, a sine wave can be used, which is continuously changed through modulation. The height or amplitude of the wave can be varied, or its frequency. The number of wave crests per second, which is counted in hertz. The varying pattern carries the message. The wavelength is the distance between wave crests and is typically hundreds of meters for radio waves. But the frequency is millions of waves per second because radio travels at the speed of light. There are very many radio waves all around us, so a receiver must have a tuner in order to isolate a particular signal, as well as an amplifier to make it stronger. Modern digital radio breaks the signal into pieces coded as numbers, which are reassembled into sound at the receiver. They are transmitted across much wider frequency bands than analog radio. This gives a more reliable signal, and it means that one digital signal can carry many programs at the same time. Radio frequency bands are allocated for different purposes. Television, for example, uses higher frequencies than radio broadcasting. ITU is where international agreements are made about allocating frequencies for the many services that use radio today, including mobile phones and other devices.